96 days until GCSE Maths Paper 1. Pause the video, have a go at this question, and then we'll have a look at it together. ABCD is a kite with diagonals AC and BD. A is the point with coordinates -3, 4, and the diagonals of the kite intersect at point M with coordinates 0, 2. Given that AB is equal to AD, which is 6.5 centimetres, and the x coordinate of B is positive, find the coordinates of B and D. Let's start by drawing a sketch of our kite. Labelling this clockwise, we'll have point A, B, C and D, where AB is equal to AD, and both of these lengths are 6.5 centimetres. When we connect the opposite points, intersection is point M, where M has coordinates 0, 2, and A has coordinates -3, 4. Obviously, I've drawn this kite facing upright, but it might be rotated slightly to the left or the right on the diagram. Let's start by finding the point B. For now, since we don't know the coordinates, let's just say coordinate x and coordinate y. The diagonals of a kite are perpendicular, which means that this will be a right angle triangle. And let's sketch this at the side. We can find an expression for each of these lengths in terms of x and y. The base of the triangle will be the difference between our x coordinates. To find the difference, we can take one value from the other. So we can write this as x minus -3. Two negatives make a positive, so we can write this as x plus 3. Then the height of this triangle will be the difference between the y coordinates. So from 4 to y, to find the difference, we take one value from the other. We can write this as y minus 4. Now with our right angle triangle, we can form an equation using Pythagoras. A squared plus b squared equals c squared, where side C is opposite the right angle, and then it doesn't matter which we label as A or B. In place of A, we have x plus 3, so this will be x plus 3 squared, plus in place of B, we have y minus 4, so this will be y minus 4 squared, and this is equal to c squared, where c is 6.5, so that would be 6.5 squared. Now we have an equation in terms of x and y, but we can't solve this unless it's all in terms of x or all in terms of y. So let's see if we can find another equation in terms of x and y. I mentioned before that these lines are perpendicular, which means the gradient of m to b will be the negative reciprocal of the gradient from a to m. To work out the gradient, this is the change in the y coordinates divided by the change in the x coordinates. Or you might also call this rise over run. The change in y coordinates from a to m, or from 4 to -2, this is a difference of -2, divided by the change in the x coordinates from -3 to 0, this is a difference of +3. So the gradient of a to m is -2/3. And because these lines are perpendicular, the gradient of MB will be the negative reciprocal of 2/3, will be positive 3/2. MB is a straight line, and the equation of a straight